Hey everyone, here is your lesson for section 11:7, circles in the coordinate plane. Missy McCarthy, Okemos High School math instructor. For this particular lesson, our objectives are to write the equations of and graph circles in the coordinate plane, and we may even use those equations to solve some real-world problems. No little video of me today. I am suffering from allergies, and I'm already going to have to edit out enough sneezing. You guys don't need to see me partially sneezing in the video. So as we get into this lesson about circles, I'm going to talk a little bit about a conversation I had with my daughter Reagan. We are moving into our new house, and I was frustrated because I don't have cell phone service in this one little area in Okemos, or I have spotty service, maybe I should say. And she wanted to know how it was possible that I could be 3 blocks over and have service, and then be at our house and not have service. So we had a conversation about cell phone towers. So say this was a tower. Say we're looking at the bird's eye view of the tower, and I had to explain this to her like you're a bird flying overhead. The tower sends out signals, and I said those signals are in the pattern of a circle all around the tower. And she said, oh, you mean like when you throw a rock in the water and circles come out from it? And I said, yes, those signals are coming out. Well, what happens is if you have one tower in one location sending out signals, another tower in another location sending out signals, I'll draw that center there, another tower in another location sending out signals, and the towers aren't close enough together, you end up with a dead zone. And she was just like, so we live right there. Yep, we live right there. And that's why if we just go a couple blocks over, we can get service. So what we're going to look at is how you would take the equation for one of these circles and plot them in the coordinate plane. So one of these circles are cell phone towers. I'm going to draw this one so that the tower is right at the origin, and any point on the circle would be the point X, Y. How do we represent the points on that circle with an equation? If this is your x-axis and this is your y-axis. So that's pretty much what we're going to be looking at in this lesson. Not as complicated as cell phone towers, but how would you graph those circles? Now I should say my other daughter, I should add this in here, did come afterwards and say, well, Mom, why don't they just make them in the shape of hexagons? Because you wouldn't have any dead zones. So she was thinking you could have a tower and the signal could be a hexagon, and then you would just put another hexagon here and then another hexagon here, and voila, we eliminate the dead zones. Obviously they have a little bit to learn about, well, waves and signals being sent out, but hey, she was thinking. Alright, so here's what we're going to do. We're going to look at, say, this circle. The center of our circle is HK. And every point on the circle is going to be XY. And then from the center to a point on the circle would be our radius R. Well, finding how long the radius is just like using the distance formula between points HK and XY. So R is going to be equal to the square root of x minus h, quantity squared, the difference in the x coordinates, plus y minus k, quantity squared, the difference in the y coordinates between the 2 points. And if we square both sides, we get the equation for a circle with center hk would be x minus h, quantity squared, plus y minus k, quantity squared, equals r squared. So in any equation that you see like this, it represents a circle where HK is the center of that circle and R is the radius of that circle. So looking at any equation, you can identify the center and the radius quite quickly if it's written in that form. So here it says write the equation for the circle with the given conditions. The center of circle J is going to be at 2, 2, and the radius is going to be 4. So our standard form for the equation of a circle is x minus h, quantity squared, plus y minus k quantity squared equals r squared. So we're just going to plug in what we know. So for this particular circle, circle J is going to be x minus 2, because this is h and this is k, quantity squared, plus y minus 2 quantity squared equals 4 squared. Or x minus 2 squared plus y minus 2 squared equals 16. And that's the equation for circle J. Let's write the equation for the circle that passes through 6, 4, and 1 negative, and has a center at 1, negative 8. So if our center is at 1, negative 8, that means this is h and this is k, but they don't tell us our radius. So all we know is it goes through this point. So here's how I do those. I'm going to set it up without knowing my radius. So I know my equation is x minus h, which is 1, quantity squared, plus y minus a negative 8, quantity squared, equals r squared. But I don't know what r is, so in order to find r, I'm going to plug in this point for x and y because I know that that's a point on the circle. So if I do 6 minus 1 quantity squared plus y would be 4 plus 8 quantity squared equals r squared, that gives me 25 plus h 12 squared is 144 equals r squared, and r squared turns out to be 169. So now I know I can finally write the equation of the circle. I really don't need r, I really just need r squared. So it's going to be x minus 1 quantity squared plus y plus 8 minus a negative is plus quantity squared equals r squared, which is 169, and that would be the equation for circle K. Alright, now let's look at what would happen if we wanted to graph this circle. X minus 3 quantity squared plus y plus 2 quantity squared equals 9. If we wanted to graph it, there's 3 easy steps we can follow. The first step would be to identify the center and the radius of this particular circle. After we identify the center and the radius, we're going to plot the center and use the radius to obtain 4 more points in our circle. North, south, east, and west, I'll explain momentarily. And then lastly, connect those with our circular arc. So, identify the center of the circle. Well, we have to identify what h and k are. It's x minus h quantity squared. So that means h is 3. Plus y minus k quantity squared. So that means k is negative 2. That's how we got the plus 2. Equals r squared. And so that means our radius is 3. Because 9 is the radius squared. Now secondly, plot the center and use the radius to obtain 4 points on the circle. So our center is at 3, negative 2. There's the center of our circle. And now our radius is 3, so go north 3, 1, 2, 3, south 1, 2, 3, east 1, 2, 3, and west. And then, as best you can, draw in the arc for the circle. So that will be the graph of that circle. Alright, let's try this one. First we have to identify our center. So my center, because I'm not adding or subtracting anything, my center for this particular circle is 0, 0. And then my radius for this circle, 16, is the radius squared. So that means the radius is 4. So plot my center at 0, 0. And then we're going to go north 4, south 4, east, and west, and then draw in our arc. And this one sucks. I don't like that one. That's a little better. Now I don't like this one. Alright, I quit. Alright, there we go. All right, last one. Let's graph this equation. Identify our center. So this x minus h quantity squared plus y minus k quantity squared equals r squared. So that means our center is going to be at -4, -1, and our radius is going to be 6. So we've got -4, -1, and then our radius, north 1, 2, 3, 4, 5, 6, south 1, 2, 3, 4, 5, 6, east 1, 2, 3, 4, 5, 6. Excuse me if somebody comes in here because the bell just rang. And 1, 2, 3, 4, 5, 6. And then draw in your arc.